Chapter 10, Section 1. Now, complex power calculation. Let's quickly summarize this. When we have a voltage V of t equals to Vm cosine omega t plus theta v, and a current I of t equals to Vm Vi Im cosine omega t plus theta I. Okay, the instantaneous power really is V of t times I of t. Okay, so we saw um, that the instantaneous power is the product of this, and then after a few trigonometric identities applying them, we saw the equation for the instantaneous power P of t to be Vm Im over 2 cosine theta v minus theta I plus Vm Im over 2 cosine theta v minus theta I times cosine 2 omega t plus Vm Im over 2 sine theta v minus theta I times sine 2 omega t. So this is the expression for instantaneous current that we saw, right? Which is simply the product of the voltage and current, and it's actually a negative. Okay, negative Vm Im sine theta v minus theta I sine 2 omega t. Now this term, okay, the term here, this is called the average power. Okay, P average. This is defined as P average. Okay, and then this is called the reactive power. Okay, let's see. This component is called the reactive power. Okay, this is called the reactive power component. Now, pretty simple, and then we went on to writing this um, in a in a more concise manner. If I call P is Vm Im over 2 cosine theta v minus theta I. So all of this I'm going to call as P. And the other term, this guy, so just this guy, I'm going to call it as Q. Okay, Q is Vm Im over 2 sine theta v minus theta I. Okay, then we can write the equation P of t as P. So because all of this is P, right? So Vm Im over 2 cos theta v minus theta I is nothing but P plus P times cosine 2 omega t minus Q times sine 2 omega t. Okay, so the example problems that we are going to look at are simply going to be the application of this. Okay, so when you're interested in calculating the power average or the term P or the term Q, that's what the example problems are going to be about. But here is the quick summary of instantaneous power, reactive power, and average power.